Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on December 16th, 2025, just yesterday. It introduces a new benchmark that stress tests whether image and video generators actually reason about physics, logic, and space. And it finds that while models do moderately well on physical common sense, they collapse on abstract reasoning, with ARC-AGI accuracy below 10%. The paper is titled MMGR, Multimodal Generative Reasoning, and as we will see later, the implications for how we train future world models are quite significant. Figure 1 shows how the benchmark turns reasoning tasks into a full generate and score pipeline. The left block outlines 3 task domains, from abstract puzzles to navigation and physical common sense scenes. The middle block illustrates generation, where image and video models take a maze input and produce either a single solution frame or a trajectory. The right block depicts evaluation, in which a vision language judge and human reviewers assign fine-grained and primary metrics, so success requires both plausible visuals and correct reasoning. Figure 2 lays out how MMGR organizes its tests into 3 domains, so it makes clear what kinds of reasoning each task stresses. The top band shows abstract reasoning puzzles like mazes, Sudoku, ARC-AGI, and math stories, which mainly require logical and two-dimensional spatial skills. The middle band illustrates embodied navigation tasks in panoramic, top-down, and 3-dimensional views that demand physical understanding and long-horizon planning. The bottom band presents physical common-sense prompts and sports clips that check whether generated motions respect everyday physics. Table 1 spells out how each benchmark task maps onto the 5 reasoning abilities and how many examples support it, so it defines the backbone of the MMGR testbed. The top block lists abstract reasoning problems like maze, Sudoku, ARC-AGI, and math with several hundred samples. The middle block covers embodied navigation tasks, each with about 100 clips that mix physical and spatial demands. The bottom block summarizes the 2 physical common sense tasks, which together round out a total of about 1,850 samples. Table 4 summarizes how well different video and image generators actually solve the 2-dimensional maze task, so it reveals who reaches the goal without cheating. The full table shows 4 fine-grained metrics plus an overall success score across maze sizes and generators. The upper block with depth-first search mazes indicates that image models like NanoBanana generally change the maze less and crosswalls less than video models, though they sometimes explore more. The lower block with Wilson mazes shows a similar pattern, where video models often achieve the goal but incur high wall crossings, which signals visually plausible yet physically invalid paths. Table 9 quantifies how well each generator solves the ARC-AGI version 1 puzzles, and it shows that almost all models mostly fail. The standout is the NanoBanana Pro image model, which reaches about 31% valid solutions, far above every video model. Among videos, Sora 2 leads with around 20%, while Veo 3 and Wine 2.2 barely register. The fine-grained columns reveal that several models can spot patterns or keep grids intact, yet their overall correctness stays extremely low, which signals shallow rather than truly systematic reasoning. Table 24 summarizes how well each generator actually navigates, and it shows that the NanoBanana image model dominates holistic success, while Veo 3 is the strongest video model. The overview of the table contrasts 4 metrics that matter together: task completeness, physical understanding, instruction following, and the strict holistic overall score. In the upper navigation tasks, NanoBanana reaches around 3/4 holistic accuracy in panoramic views, while Veo 3 is the only video model with non-trivial holistic scores. In the lower, harder tasks like 3-dimensional navigation and SLAG, every model drops sharply, which signals that long-horizon, instruction-faithful navigation remains largely unsolved. Alright, the big takeaway is that current image and video generators look smart, but reason poorly, especially on abstract puzzles and long-horizon navigation. MMGR gives a unified, reasoning-aware benchmark that can steer future models toward causal, physically grounded world simulation. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.